So if we look at this practice exercise, it asks us to balance the chemical equation for the reaction between P4O10 solid, which is tetraphosphorus dicoxide, and liquid water that produces phosphoric acid, and they give us the formula H3PO4. So the very first thing we need to do is write out the balanced chemical equation. So we're told that tetraphosphorus dicoxide is reacting with liquid water. So we know the formula for water, and we know that if two chemicals are reacting, they're going to be on the left-hand side of the arrow, and they're going to be separated by this plus sign. And we're told that phosphoric acid is forming. So after we get our balance, well, it's not balanced yet. Once we get our chemical equation, the next thing we want to do is we want to count the number of atoms of each element on each side of the arrow. Sometimes chemical equations are already balanced the way that they're written, all with coefficients of 1. So if we count the number of phosphoruses, there are 1 times 4 and 1 times 1 on the product side. So our phosphoruses are not balanced. If we look at oxygen, I have 1 times 10 from my binary covalent compound here, and they have 1 oxygen from water, which gives me a total of 11. And then on my product side, I have 1 times 4, which is 4. Hydrogen, I have 1 times 2 from my water, which is 2, and then 1 times 3 from my phosphoric acid, which is 3. So clearly, this is not balanced. So the first thing I'm going to do is I'm going to balance my phosphorus. Why? Well, I just sort of know the way that it's going to happen, but I would definitely leave oxygen for last because it's the most complicated and it's in every single chemical. So I want to do oxygen last. So when I balance my phosphorus, I'll put a 4 in front of my phosphoric acid, and then that gets me 4 times 1, 4 phosphoruses on my product side, and now my phosphoruses are balanced. Now I'm going to look at oxygen last, but what that does to my hydrogen is now I have 12 hydrogens on my product side, 4 times 3. So I'm going to go ahead and balance my hydrogen by placing a coefficient of 6 in front of my water. Now I have 6 times 2, I have 12 hydrogen, and my hydrogens are balanced. The very last thing I'm going to look at is my oxygen. This coefficient of 4 in front of the phosphoric acid gives me 16 oxygens on my product side. When I look at my reactant side, I have 10 from my tetraphosphorus dicoxide, and I have 6 times 1, which is 6 from my water. So when I add those, I get 16, and I'm not sure why it says 116. That's just a typo. I'll just put the little hand in front of there. Now I have 16 oxygen on each side, and my entire equation is balanced.